All right, here's example number 6 from 15.4. And we talked in our last video about negative area versus positive area, area below the x-axis versus area above the x-axis, and how we have to be careful depending on what the question asks us. So if you look at example number 6, it asks us to find the total area between the x-axis and the graph of f of x, if f of x is x cubed, and we want to find the area from x equals -2 to x equals +2. So in this one, they didn't give us a picture, so I actually drew the picture. At this point, you should know what an x cubed graph looks like, and so I know that it kind of looks like a little snake, and so you should have the same idea on your picture. I know that I want to go from x equals -2 to +2, and I want to find the total area between the x-axis and the graph. And so now, if I'm looking for total area, I'm looking for all of this amount plus all of that amount. Now, if they asked you just for the net change, what was the integral from -2 to +2 all in one, and we did that, and we evaluated, we used our fundamental theorem of calculus, and we found the antiderivative, we evaluated our upper limit minus our lower limit, what would end up happening? Well, we end up getting 0 area, right? Because if you look at the picture, you've got some area that's below, negative, and you have just as much area above the x-axis, positive. And so they actually end up zeroing each other out, canceling each other out, right? And so if I asked you for net change, there would be a 0 net change. This is kind of like you made some money, but you lost some money and you broke even. Or you walked 5 steps to the left, but then you walked 5 steps to the right and you ended up back where you started. So I have a 0 net change. But the question wasn't really asking me for net change. The question was asking me for total area. And so anytime I see that they're asking me for total area, I've got to do the problem a little bit differently. I've got to first figure out where am I above the x-axis versus below the x-axis, and then I've got to set myself up a bunch of different integrals depending on where I'm at. And so when this question asks me for the total area, I've got to set up 2 different integrals. I've got to set up an integral from -2 to 0 of my function and find that area. But then I have to set up another integral from 0 to 2 and find that area. Now, when I go to find the integral for each of these pieces, the first one from -2 to 0, remember, was underneath the x-axis. We saw that in our picture. And so it's going to end up being a negative area. But I don't want to negate all the stuff that happened, all of the area. So what we have to do is after we evaluate our integral, after we find the antiderivative, we've got to take its absolute value so that we can consider all of its change and not the negative amount of its change. So I'm going to evaluate each integral. I'm going to find the antiderivative, and I'm going to evaluate it from the upper limit to the lower limit, my fundamental theorem of calculus. In this first piece, I'm going to plug in my upper limit, plug in my lower limit. But remember, you should end up getting a negative value, and then we have to take its absolute value. In my second piece, I'm going to evaluate it from 0 to 2. So I'm going to plug in 2, I'm going to plug in 0, and subtract them. And let's see what happens. So in this first piece, I ended up getting actually a -4 area. That meant that I have 4 square units of area, but it happens to be underneath the x-axis. But I needed to make sure that I include that area with an absolute value. So I'm going to take the absolute value of that, and then I'm going to add it to the area that I got from 0 to 2, which happens to be 4 also. And so once I take the absolute value of the negative piece, I end up getting 4 plus 4 for a total area of 8. Remember, my net change was 0 because I included the positive and the negative version of each. But if they ask me for total area, that's what they asked me in this problem, I want to make sure that I separate it into 2 different integrals, the stuff that's below negative, the stuff that's above positive, do them separately, make sure that I take the absolute value of the negative area so that I can add them together to get a total of 8.